Right. So 7.7 is the next lesson we're doing. So yesterday we talked about what did we talk about yesterday? We talked about the common base, right? We said something, a logarithm can have any number as its base, but we said that 10 is the most common base, right? Because so many things are just like 10 to the power of, 10 to the power of, 10 to the power of, all right? Now, there is another special situation when it comes to bases, and that is base E. Oops. Okay. So, we've come across, a constant like pi, right? And we know pi is an irrational number, right? 3.14159, blah, 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 that never ends. And we know that that specific value has meaning, right? Because it's like the circumference of a circle divided by the diameter and so on. So that's a irrational number, pi, that has a special meaning and a special name. Today we're going to learn about another one, e. All right, so this is just a lowercase e, never capital. It's another irrational number, and it has a value of approximately 2.718. This is also one of those things that never ends. It's just like pi. This is e. Pi is 3.14159, blah, blah, blah. This is 2.718, blah, 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 blah. It never ends. And this number is e. So we said yesterday, a logarithm can have any number as its base, right? So you can have, for example, log base 2 of x. You can have log base 10 of x, okay? And then sometimes you have log of x, and the base is this special number e, 2.718, blah, 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 blah. That base e is the natural base of the logarithm. I mean, yes, 10 is the common base, but e is the natural base. And it's like a logarithm and e are like soulmates, right? And they're just at their most like natural state when they're together, okay? So much so when you have log base e of x, we abbreviate that and we just write it as ln of x. So log base e just gets abbreviated to ln. Why ln? Because this is called the natural logarithm, but it's in French, logarithme naturel. So ln, all right? Natural logarithm. And that ln is our favorite thing in the world starting today, okay? So ln of x, all it is just log base e of x, okay? So here are some properties. When you have e to the power of ln of x, that's just x. E and the ln just go away. When you have ln of e to the power of x, that's just x. When you have ln of e, that's just 1. Okay, why? When you have ln of e, right, that's the same as log base e of e, right? And what's log base e of e? What should be the exponent of e so you get an e? 1. That's why ln of e is just 1, okay? This you just have to know. If you're walking down the street and somebody taps you on the shoulder and says, hey, ln of e, you just go 1, okay? ln of e to the x is just x. Again, because this is just log base e to the x, right? And when this x comes down, this is log base e of e, which is ln of e, which is 1. All right? Okay, so let's write each expression in logarithmic form. Okay, what is the exponent here? Nope, x. X is the exponent, and that's always going to be the answer of the logarithm. And so this is going to be just ln of 23. Okay? Yeah. So here, the exponent is 4. That's the answer to the logarithm. All right? And here it would have been log base e of x. Now it's just ln of x equal to 4. Okay. Write each as an exponential form. So take a look here. What you have here is basically log base e of x, right? This is the exponent. Every exponent needs a base. So e to the power of 1.2528 is equal to x. Okay, in this one, what's the exponent in this setup here? Huh? X. What's the base then? Nope. E is the base. So e to the x is 25. Okay? All right, so let's write these as a single logarithm. It means we're going to condense the logarithm. Same as with the logs, all of these coefficients become exponents. So I have ln 1/2 to the power of 3 plus ln 6 squared. Now, remember when I condense, I write one logarithm. So I have the first one, it's positive, so it'll be a numerator. And then the 6 squared, is that going to be multiplied or divided by this? Multiply 6 squared. Okay? So this is going to be ln of 1/8 times 36, ln of 9/2. Okay, here. This goes up here. So I have ln of 3 squared minus ln of 4 minus ln of y. Write 1 ln. The 3 squared, that's a 9. Will that be a numerator or a denominator? A numerator. How about the 4? A denominator. How about the y? A denominator. So that's the answer. ln of 9/4y. Okay? Okay, let's solve some equations. All right, what do you guys think we do first here? Move over the 4. 3e to the negative 2x equal to 6. Divide by 3. Divide by 3. E to the negative 2x equals to 2. Yeah? Now what? Now I have an exponential function like this. I have two ways of solving it. One is take the logarithm of both sides. What is the base here? E. So what type of logarithm do I take? ln, right? It would have been log base e. Now it's going to be ln. ln and e together, they just go away. So I have negative 2x left equals ln of 2. Divide both sides by negative 2. X is ln of 2 over negative 2. Let's plug that in the calculator. Go ahead and take out your calculators. Okay, so ln is the button right next to okay, so ln, you have to do control, and it's the e to the x button here, right next to the logarithm button, right there. You see that? Control, and this red one here, okay? Because you see that? 10 to the x and logarithm are inverses. E to the x and ln are inverses. So here I have ln of 2, and then here divided by negative 2. Again, make sure that you typed it in the way you meant to type it in. And here we get negative 0.3466. Okay, questions? Yep. E is just a number like pi is 3.1415, like that special number. because there is another expression, 1 plus 1 over x to the power of x. And when you graph that, it looks like this. And then it levels off at 2.71818, blah, blah, blah. That number is E. Now, where does that expression come from? That's an expression that shows up a lot in math, and often we have to look at the end behavior of it, and so that's where E comes from. Okay? Yep. Okay, so here we're going to add 12. 3e to the 4x is equal to 27. Divide by 3, e to the 4x equal to what? 9. What are we going to do here? ln. ln. So on the left side, what do I have left? 4x equal to ln of 9. X equal ln of 9 over 4. So x is about how much when you plug it in? That, okay? All right. And so we saw several examples, right? When we had, log base 10 of where that applies. One was the Richter scale. Another one was pH. Another one was decibels. Another one, right? There are so many others. And when it comes to E's and LNs, I mean, there is just a world of things that apply to, that this applies to. I mean, like a world of things. Like half-life is this. The way things spread, COVID, flu, right? All of that. It's all E's and LNs and all that good stuff. Rumors, the way a rumor spreads has to do with an LN, all right? So many cool things. And then, some more that's coming up over here. All right. So now let's solve some logarithmic functions. Divide by 2, divide by 2. ln of 5x is equal to 3. Now I have an exponential, now I have a logarithmic function. What is the answer to a logarithm? An exponent. If 3 is an exponent, every exponent needs a base. What's the base? E. E to the 3 is equal to what? 5x. All right. Do you see how natural, how natural it is turning out to be? Get it? Like the natural base. Okay. So x is e cubed over 5. Huh? Okay. Okay. All right. So, what are we going to do here? Multiply by 3. So ln of x is equal to 6. Now what? What's the exponent here? 6. Yep. E to the 6 equals x. And so how much is e to the 6 these days? 0.88. Good. Okay. Normally we go to 4 decimal places. I mean, I don't know when that was decided, but it was decided. Okay. All right, now for some word problems, because what is math without word problems? Again, these are just all of the ways that we can describe the natural things that happen in the universe, right? And so, of course, they all apply to real life situations. Okay, remember in the last sections here, okay, go ahead and put your calculators down for a minute so you can listen up. Okay, remember in the last couple of sections, right, we learned about compound interest, right? And we said, you had money in a bank and it's being compounded annually, quarterly, daily, and so on, right? So if it was being compounded annually, the bank was paying you 1 time. Quarterly, how many times was the bank paying you? 4 times. Daily, how many times is the bank paying you? 365 times, right? Now, so imagine that. Imagine your money is in a bank account, and every single day, the bank computes interest and pays you money every single day, right? Monday, Tuesday, Wednesday, Thursday, 365 days a year. And you're like, oh my God, this is amazing. So then you find out about another account where the bank pays you interest, not daily, not hourly, not by minute, but continuously. So now, again. How many times a year is that? Infinite amount, an infinite amount. Okay. So when that n, remember it was like compound interest was a is equal to p 1 plus r over n to the power of nt. When that n turns out to be infinitely large, okay, this whole thing, look at what that reminds you of. That kind of looks like this I was telling you about, right? 1 plus 1 over x to the x, 1 plus 1 over n to the, right? So that becomes an e. And so the new formula then becomes a equals pe to the rt. Okay? Students lovingly call this the APERT formula. But this is one, again, where you just have to like memorize. The answer is not my concern. My concern is you listening. Okay? Thank you. So, all right. So this is where you have to see the word continuously. Now, interest is only one place where we use this, right? But when population grows continuously, we use a similar formula. So you have to look for the word what? Continuously. When you see the word continuously, E has to go in there somewhere, all right? So take a look at this one. You deposit $700 into an account that pays 3% annual interest, compounded continuously, right? So now we have to use PE to the RT. And now you're like, oh my God, I'm going to make like an infinite number of, dollars here. Let's see. So what is your balance in 8 years? So A is 700 e to the 0.03 times 8. And when you plug this in, I want you to plug it in one shot. So 700 times e to the power of 0.03 times 8. Okay? And that's how much money you get. A measly like $189. All right? You don't make that much more money than you would have. All right, how come I can't get these? Oh my gosh, how come I can't get it? All right, whatever. So A is $889.87. Okay? So how long will it take the balance in your account to reach at least $1,200? Okay. Now we are no longer going to solve this using the graph. Okay? This is why I didn't want you guys to go ahead. No longer are we were solving this using the graph because we didn't know how to solve the equations before. But now we just learned how to solve logarithmic equations and exponential equations, right? So this is going to be 1,200 equal to 700 e to the 0.03 t. Okay? So now you can always cancel out an equal number of zeros. We're going to divide by 7. So I get 12 over 7 equal to e 0.03 t. So what do we do now? Take the logarithm. Log base what? ln, right? So ln. So I get ln of 12 over 7 equal to 0.03 t. And so now how am I going to solve for t? Divide by 0.03, divide by 0.03. So t is ln of 12 over 7 divided by 0.03. So now let's go ahead and plug that into the calculator. So I get ln of 12 over 7 divided by 0.03. There we go. 17.9666. Okay? So it's about 18 years. All right. So in this chapter, we learned two skills. A, we learn how to solve these things using the graph. F1, F2, intersection, boom. Then we learn how to solve this using algebra and the equations. This might not seem like a big deal to you, but coming from your future of where you guys are going, this is the biggest thing ever. It is all over calculus, all over. So you have to be able to solve these things like muscle memory, all right? This thing, all right. So how much would have been deposited in order to reach a balance of 1,500 after 12 years? So now this is the final amount, or P, and we want to find, this is A, and we want to find P. Okay, so 1,500 is equal to P, e to the 0.03, 12. Right, so how much should you start with so that 12 years later you get $1,500? So now I need to solve for P. So I need to divide both sides by this. Okay, so P is how much? Yes. Okay. Whose phone is that? Okay. All right. Questions on this? Okay, now look. It's very, very possible that you have a question like this to solve with no calculator. Okay? In that case, it's okay. You can just leave it like that, right? You can just leave your answer like that. Because like most things that you learn starting in Algebra 2 and up, it's not about the final answer, it's about the process to get you there, all right? Anybody could plug this into the calculator and realize, okay, it's 17.9. That's not the issue. The issue is getting into this situation in the first place. How do you use algebra to get to this? And I can't tell you how important this is. The next lesson, look, word problem is only word problems in the next lesson. Only word problems, right? And so this is why it is so important to be able to do these. Okay? Welcome to the real world, guys. Welcome to Algebra 2 Honors. Yay, we made it. Okay? Of this chapter. Yeah. All right, so homework is from the book.